This is going to be a fairly quick video for the isosceles triangle, something that we discussed in class when we were proving the isosceles triangle in Unit 3. We looked at it in a more conventional way. And as if you recall, we dropped an angle bisector right here, called these two angles congruent, right here and right here. And what we did was, given that these two legs are congruent, we wanted to basically prove that these two base angles were congruent as well. And the converse is going to work out the same way. So all we had to do was just use the reflexive property right here, and then we had ourselves side angle side. But there's another way that we started to discuss in class that we went a little bit too quick over, but it's the same thing. So we're going to start off by constructing a circle. So I'll construct a circle here, and I'll get rid of this compass. And by virtue of the circle, I went and created, I'll go ahead and create another radius here. I have two segments that are of the same length right here. So these two are basically, both radiuses, of course, are congruent. And you can see where I'm going with this. Now I'm going to go ahead and extend out this and create my chords. I mean diameters. Yeah, same thing. Diameters. I created my diameters. This is a central angle. I'll go ahead and label my points. All right. I'll call this circle A. Okay, and we'll call this B, C, D, E. Okay. Now another way to prove isosceles is, of course, using the circle. And the circle is very handy in proving just about almost everything we do in this first semester. And I want to prove my base angles are congruent. So given the definitions that we learned in Unit 1, that central angles have the same measure of their arc. So this is the subtended arc for this angle right here. This angle right here is the subtended arc, and this measure right here is the subtended arc. The other definition we learned that when we had inscribed angles, such as we have this angle right here, call that angle 1, and call this angle 2. The inscribed angle, the subtended arc of the inscribed angles right here, okay, for angle 1, and the subtended arc for angle 2 is this right here. If we can prove the arcs are congruent, we're going to absolutely prove that the angles are congruent as well. Well, using the definition of central angles, we have angles 3 and angle 4. Central angles are equal to the measure of the arc, so the measure of arc EC and the measure of arc DB, okay, are going to be equal to the degrees of this. Now we know that angle 3 is going to be congruent to angle 4, definition of vertical angles. Then we would go, like this would be step 3 and this would be step 4 or something. Then we can say that measure of DB, there goes my dyslexia, is equal to the measure of EC based upon the definition of central angles. Okay? Then we can go and say, basically using the converse you want to say, measure of angle 1 is equal to the measure of angle 2 because of the inscribed angle definition. So that is one way to go about proving the isosceles triangle, as opposed to the more traditional way of doing side angle side. Okay, I'm going to upload this real quick.